and welcome to Learning During Lockdown. So, the topic that we are going to study today is called sets. So, we're done with type 2, we're going to move on to the Venn diagrams. Okay, what are Venn diagrams? Essentially, Venn diagrams are just a means or a way to display the elements within sets. So, yeah, and they also show us when two sets overlap, or rather the common elements within two sets. So yeah, okay, so this cool diagram that you see here is called a Venn diagram. Since there are two sets, that's why it has two circles. If there are three sets, then we will just add in three circles. Well, we'll do that later because that's like the complicated part. So we're just gonna learn the initials first. So something will with three sets will look like that. Yeah, I think the diagram for two sets looks better. Anyway, okay, so E, as we all know, it represents all elements in the universal set. The portion shaded blue shows the part that represents only the elements in set B, and then the green part represents the elements which are only in set A. Yeah, and then this orange, I guess it's orange or it's brown, who cares? So yeah, it represents the elements which are common to set A and set B. So yeah, and then the unshaded part, the unshaded part, it represents the elements which are within the universal set but not in set A or set B. So yeah, perfect. Moving on, we're gonna change the color, move to, I don't know, let's do green. Okay, so let's do the last question for the day. Okay, so given that the universal set states that it has positive integers less than or equal to 15. Now we're gonna try and solve this question using Venn diagrams. Yeah, that should be exciting. Let's do it. Let's quickly draw a Venn diagram. Since it has two sets, so we will only have two circles. It's gonna be this and this. And I don't like the exterior. Let's get rid of the lines. I want them to be longer, so yeah. Okay. That looks better. This is E, the universal set. It's not written as E, but yeah. We're just going to write the elements, so it's easier for us to write them within the set. Okay. So we have x is a multiple of 3, and it has to be less than or equal to 15. So we've got 3, 6, 9, 12, and less than or equal to, right? So also 15. Now let's write down the elements of set B. They have to be less than or equal to 15 and a multiple of 2. So 2, 4, 6, 8, 10, 12, 14. So yeah, all done. Now we're going to highlight the elements which are common for both A and B. Okay, so 6 is common, 12 is common. Oh, and that's it. Cool. So we're going to write down the common bits in here. I'm just gonna remove that. Okay, so yeah, the common bits are 6 and 12, and then the elements which are only within A, you're gonna write them here. Oh no, to remove everything, come on. Okay, yeah, so they are 3, 9, and 15, and for B they are 2, 4, 8, 10, and 14. Okay, you must have noticed that there are a few elements which are not within A nor within B. So which are they? Let's count from 1 to 15. Okay, so we've got 1, 2 is in B, 3 is in A, 4 is in B, 5 is nowhere, 5 is nowhere, 6, 7 is nowhere, 8, yeah, 9, 10, 11, 11 is nowhere, 12, 13 is nowhere. So yeah, we've got N of E, it was 15, N of E was 15, and then so the overlapping part we only counted within one of the sets, so either set A or set B. So I'm gonna consider this part and I'll count all of this first. Oh no, don't go away. Okay, so essentially I'm going to count all the elements within B first. So let's do that. N of B is equal to 1, 2, 3, 4, 5, 6, 7. So 7, and then now if there are 7, 8, 9, 10 elements within A plus B, so essentially the external part should only have 5 elements, which is exactly what we see here. So that means our solution is correct.